Okay, I just finished a 11-minute video and it was recorded at the wrong size. So instead of going through everything raw like before, we're just going to try this again. Um, and I'm going to kind of go through what we did, and it'll be even shorter now, which is nice. So we're going to attack this ideal design for a current sensing module. That's not what we're attacking. Toggled the wrong one. We did that last video. We were working on the sampling, and originally I had thought that it would be good to do it at a hard-coded sampling rate. And the whole idea was, well, here, the whole idea before was, hey, let's shoot for 100 seconds, 90-minute flight, 90-second flight, 10 seconds round. I drew up this wonderful graph, which is ugly when I see it a second time, and the whole idea was from here, 100 seconds. So ignition, apogee, land was 90 seconds, and then another 10 seconds after that. And then started thinking through that more, and I realized as I started listing out the possible ways we can do this, there's and I guess one thing that needs to be explained, what's the whole idea of this metering, right? Like why are we metering it in the first place? Well, we want to know. We want to know whether our batteries are going to last and how many flights they're going to last. And the great part is with our electronics is that we can test that before we ever put it on the pad. We can test how long it or how much wattage it draws when it's just sitting idle versus when it's in action versus when it's sitting idle. And we can get a real profile for how long everything's going to last. And we can measure it before we ever get out on the field. With that being said, I kind of thought through a couple modes of operation. One of them was to collect the data at the same rate from when we powered on at the pad to stop collecting on shut off. So that would be same sampling rate, just constant. What's the negative of that? Well, when you're sitting on the pad, you really don't need high sampling rate because it should be a pretty constant power draw. You'll have spikes in there, but in general, you kind of want to. You're probably not writing to storage. You're probably not sampling as fast. You're not sampling everything. You're going to use less power when you're sitting on the pad. If you're not, then it's poor design. So the second way I thought of it was, okay, we can have two modes. You have a rest mode and an active mode, which would be hard-coded samples per second. The rest mode would be less samples per second, active mode would be more samples per second, and then we could just toggle that through an external pin. And then I thought more through that, and I was like, well, that's not quite perfect, because we're still hard-coding the samples per second. So what I landed on was we want to expose communication to the programming modes, and we essentially want to be able to use code from another device to set modes on this device. And that would allow us to define a mode like rest mode and set a certain samples per second, and an active mode set a certain samples per second, and maybe even like a overactive mode, which would set another different certain samples per second. The engineering trade-offs here, if you look from the top to bottom, we can control everything. We can tell you this is how long this module can last based on our internal storage we have running on it. This is, we're essentially setting the terms completely. But we're not dynamic enough to work for almost any flight or any application. If we move towards the bottom, the risk we run is the people that are running this device now have to have an idea of how much storage we have, which they should already because they have to store in other ways. But they get full control and they don't have to waste writes and power when they don't need to. and they can really jack up samples per second at really critical moments where they really need to see how much power is being drawn. So we kind of landed on this saying, hey, we're just going to expose a couple pins here to allow you to set modes on our MCU and programmable modes. And that will be kind of something that needs to be done on our firmware side. And then we need to make a library to make it easy to interface with. So, but that's all way down the road and probably not even part of this video series, to be honest. We're just designing it and getting a board fabricated. So we have gotten the board requirements done. There's a couple more minor decisions that need to be made just from a bill of materials standpoint when we get to that, but we are now officially on to our bill of materials. So in the next video, we're going to hit that. So thanks for following along, and I will talk to you guys next time.